Baldwin. It's calculus class. Okay. So I thought it was Saturday Night Live for a second. Okay, here's our topic for today, differentiation rules, and you know a lot of these already, I'm sure. So we're here, or we're there. Come back. We're here. Okay, go away. So let's start. Okay, you tell me, you know this stuff. What's the derivative with respect to x of any constant? 0. Why, by the way? Because Miss P sets up. No, there's a reason. Why? Because think of this function. Say it's y, it's like 2. We're talking about the function y equals 2. What does that look like? Or y equals any constant. What does that look like? They're all straight. Sorry. That's not what we're looking for. More info. More precise. All lines are straight. Thank you. But that's not the issue. What? What's 0? Yeah, why? Go with that, man. Don't. You're there. You're almost there. What kind of line is like y equals 2? What does it look like? They're all straight. We went through this already. But horizontal, right? And horizontal line has a 0 slope everywhere. So anywhere you draw the tangent line to the horizontal line is itself, it's got the same slope at 0. Or you could think of it this way, couldn't you? Would this be the same question? What's x to the 0? Not 0. 1 times c, it's the same question. But what if you use the power rule? What happens with the 0 when you take the derivative of x to the 0? The 0 goes out front, and everything becomes 0 when you multiply, right? 0 c x to the negative 1, but that's still 0, right? So in other words, that presupposes the power rule that you know. What do you get? X to the n's derivative. N is a constant. X is a variable. N x to the n minus 1. That's an n, okay? Don't get crazy. It's my handwriting, sorry. Sue me. Alrighty, good. Now, what about maybe not so obvious rules? This isn't obvious, but we've demonstrated this by doing a million examples like this, right? This should be obvious. How about this one? Is this obvious? If f of x is a constant times some other function, what's f prime? Do you know? If you don't know, how do you find out? How do you take the derivative of stuff? The limit thing. All right, so do you know or do you not know? You do not know? Well, let me remind you that you do know. For example, if y is x squared, what's y prime? 2x. But what if y is 3 times x squared? What's y prime? 6x. What's happening? If I dilate the function by 3, I dilate the derivative by 3 also, right? All right, so in other words, it's simply c times the derivative of g. Whoops, that should be derivative of g. No. Okay? If you know that the derivative of x squared is 2x, then the derivative of 3x squared is 3 times it. Right? That's the rule. Now say you're not sure about that. Let's prove it. If f of x is a constant times g of x, right? We're going to prove this. Prove if this, then this. And you're going to use the definition of the derivative, all right? So how are you going to write f prime? How do you write f prime? It's what? The limit as h approaches 0 of what quotient? What goes in the numerator? This is f. So what do you write? How do you write f of x plus h minus f of x? C times g of x plus h minus c times g. All over h. Good. All right. Now notice what you got here. You got a c here and you got a c here. What can you do with it? What's your favorite f word? Factor. Right, that's your favorite f word. So take out c, and what's left? that c is independent of h, so I'm just going to take it all the way out. And what's left is this. What does that look like? Who is that? That's the derivative of g, right? So the derivative of a constant times a function is the constant times the derivative of that function. That's our guess. We proved it. All right, we're good at this. That was a proof. Prove it. Now, this is not a course in theory and proof, theory and proof, theory and proof. It used to be when I took it. And we're going to do a little bit of that here and there, but we don't get to do a lot of that. Unfortunately, we don't have the time. This is more a course in numerical methods and applications, believe it or not. All right, so anyway. How about this one? Do you know this rule? If, let's see, what am I going to call it? How about h of x equals f of x plus g of x, then, do you know what h prime is going to be? Any ideas? F prime plus g prime, exactly. Is that what you said? See? Yep, that's what it is. Look, let me show you that you know this. What if h of x is 1? What's h prime? 0. What if h of x is the sum of two functions, like 1 plus x? What's h prime now? It's technically this derivative plus that derivative, but that is 1, right? All right, what if h of x is maybe a little more complicated? 1 plus x squared. What would you say h prime is? 2x plus 1, or technically 0 plus 1 plus 2x. Or 1 plus 2x or 2x plus 1, whatever, right? So that's our guess. So the derivative of the sum of two functions is the sum of their derivatives. That's our guess. Can we prove it? Let's see, let's prove it. Prove if h of x equals f of x plus g of x, then h prime is f prime plus g prime. How are you going to prove it? Just like last time, what did we do? How are you going to write an expression for h prime? You're going to use what? The definition of the derivative as a limit, right? Okay, so let's do it. The limit as who? H goes to 0. All right, what goes in the numerator? It's this guy at x, evaluated at x plus h, right? So what do you write? F of x plus h plus g of x plus h. Okay, that quantity, right, this represents h of x plus h. Don't confuse this h with that h. This is a function, this is a constant. Sorry, that's unfortunate, but there you go. That's a constant, that's a function, right? But anyway, this represents h of x plus h. What do you follow that with? Minus h of x, the function itself. And what is that? F of x times g of x, okay? Sorry, plus g of x, sorry. And don't forget, it's all over h. Now notice what we're trying to get. F of x plus h minus f of x over h, isn't that what that is? So we've got it. What's g of x minus g of x? What's g of x plus h minus g of x over h in the limit? It's g prime. So I'll just make that obvious. Just rearrange it a little bit. The limit, as h goes to 0, of f of x plus h minus f of x over h. I'm just taking this piece minus this piece over h, plus the limit, as h approaches 0, of this piece minus this piece, g of x plus h minus g of x all over h. So is our guess correct? That's our guess. Is it correct? Yeah, because what's the name of this? You rename this how? That's f prime. That's by definition f prime. Plus g prime. That's it, done. Yeah? You know the definition of the derivative of f, don't you? There it is. And so if that's the definition of the derivative of f, that's the definition of the derivative of g. It's in there, just show it, you know. All right, well, that was actually sort of easy. It gets interesting when you do the product rule and the quotient rule, stuff like that. Let's try that. Do you know the product rule? Let's see. Well, let's find out. Let's see. If h of x is f of x times g of x, then h prime is what? Let's see if we remember. Let's try one over here. I'm going to say, what if y is x cubed? What's y prime? Do the power rule. What do you get? Just the power rule. 3x squared. All right, now let's be silly. What if it's x times x squared? Is that the same question? Isn't x times x squared x cubed? It's the same question. So what's y prime? Now let's do the product rule. First times derivative of the second plus second times derivative of the first. What's that going to be? 1. Well, what is this if we multiply this out? 2x squared plus x squared is 3x squared. Same thing. So you know the product rule, don't you? First times the derivative of the second plus the second times the derivative of the first. If we define it this way, there's the first, there's the second. Okay, can you prove that? That's just our guess. All right, but have you ever proven that? Yeah. Here we go. Hang on to your hats. You ready? Can I move up? Okay. We're going to prove it. Prove if h of x is f of x times g of x, then h prime is f times g prime plus g times f prime. How the heck are you going to prove that? Well, the same way we've been doing it. Let's find h prime by definition. Now, if this is h, how do you write that out as the limit? You know, the limit as h goes to 0. What goes in the numerator? This is h now. I need h of x plus x. It's h of x plus h minus h of x. F of x plus h times g of x plus h. What follows? Minus, right? F of x times g of x. All over h. Fine. Okay, now this doesn't really look like that. Unlike before, right? Where? Like this one. This looked like this almost instantaneously. Right? It was like one little step and they were the same thing. That's not so obvious here. Alright, so if it's not so obvious, you know what? Instead of going from h to h prime, what if we go to the end? Let's see what it's supposed to look like. Let's write this thing out and see what it's supposed to look like and see if we can get from there to there. I'm going to write h prime using this. Okay? In other words, it's f of x times g prime, but g prime is the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay, so that's this times this plus g of x times f prime, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, now does this look at all like this? This is what I'm getting when I use this. This is what I'm getting when I use this. Can I make them the same? Are they in fact the same? Now let's see. What if I take f of x and I distribute f times g minus f times g. F times g minus f times g. It's in here. This is good. But wait, what's this here? Distribute the g now. And you get g times f minus g times f. Well, there's a little bit more going on then, huh? How am I going to get this in here? Well, remember when we rationalized stuff? How do you rationalize 1 over rad x? So you don't have a radical in the denominator. You multiply top and bottom by rad 2. In other words, you multiplied by, what's rad 2 over 2? So rad 2 over rad 2? That's really 1. You know how to multiply by 1, right? That was honors math 1, first grade, right? But honors math 2, second grade, they also taught you how to add 0. First you have to know how to multiply by 1. What happens when you multiply by 1? Nothing. What happens when you add 0? Nothing. I'm going to add 0. Are you ready? Okay. Here's my weird 0. It's going to get me from here to here. I'm going to get rid of this, but I'm going to end up with this eventually. I'm going to get this out of my way. Okay, here it is. Hang on to your hats. Equals the limit as h goes to 0 of this ginormous maniac thing. Okay, here it is. This f of x plus h times g of x plus h. Now hang on, I'm going to make this up. Minus f of x plus h times g of x. Why did I do that? Where would I get the idea to do that? Because what happens? There's a common factor of f of x. That's what I wanted here. And then what's left? G of x plus h minus g over h is g prime. That's the hint. I'm trying to get to this, right? All right, but wait, I messed this up. I subtracted stuff. I thought I was going to add 0. I subtracted stuff. That's not adding 0. That messed it all up. I want to do nothing. I want to add 0. Do nothing. How do I fix it? I minused it already, so add it. Okay. Now notice how good this is, how convenient this is. Look at this. So are we in agreement that I just added 0? It looks weird, but I didn't do anything. And don't forget this term is still here. So between these two terms, I just added 0. Is that legal? Okay, fine. If you factor out f of x plus h, you're left with g of x plus h minus g of x over h. What's the common factor here? G of x. If I take out g of x, I'm left with f of x plus h minus f of x over h. That sounds familiar, doesn't it? Oh, okay, so let's make that clear. Let's write it that way. The limit as h goes to 0. Okay, I'm going to factor out the f of x plus h and write what's left. G of x plus h there, and minus g. And that's over h, right? Then there's a plus here. And you said factor out the g's, right? So factor out the g. And wait, hang on. Yeah, let's leave it like that. Okay. And then take out the g and what's left? F of x plus h, what? Minus f of x over h. Well, in the limit, what happens when is this a plug-in limit? Can you plug in h as 0? Here? What do you get? F of x, which is what you wanted. Okay. Compared to what you wanted. And in the limit as h goes to 0, what is this? G prime, that's what you wanted, right? Plus g of x, there's no h here to worry about, it's already g. Right? And then, whoops, that's just a g. What happened there? Got a little g prime-ish. And then as h goes to 0, this limit is what? F prime, that's what you wanted. You're done. That's it. There it is. Because you know the definition of the derivative of f. You know the definition of the derivative of g. Just by definition, that's all it is. So what did you get? In the limit, this is f of x. This is g prime. Plus, the limit didn't affect this. It was g of x all the way. And f prime. First times the derivative of the second, plus the second times the derivative of the first. Q, E, D. Why do they write Q, E, D at the end of a proof? What the hell does that mean? QED is Latin for quod est demonstrato. Nobody takes Latin no more, huh? No? Quod, that, est, which is demonstrato. Demonstrated. That was proven beyond a shadow of a doubt forevermore. You don't have to prove it again, just use it. Okay? Alright, are you ready for the pièce de résistance? Who takes French? Okay, here we go. Let's do the quotient rule. Okay, this is where it gets really, you thought that was hairy? This is where it gets hairy. Alright, if h of x is f of x divided by g of x, then what the heck is h prime? You know the rule? Hi-ho. It's off the work we go. There's a song for this. Low, D high, minus high, D low, over low, 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 low. Too many lows, but that's the song. All right, so that's the song. I bet you it's on YouTube. We'll look it up. So anyway, it's low, D high, minus high, D low, over low, low. Low times low is G squared. All right, can we prove this? No, we can't. It's beyond our ability. I beg to differ. We can and we will. Damn it. Okay, and let's see what you did. This is on the air, and it's cursing. All right. H prime equals... Question? Was there a question? Okay. Okay. So that's the rule for differentiating a quotient of two functions, right? Okay, let's see if we can prove it. Just use the definition of derivative. You write the limit as h approaches 0 of what? What are you going to do with this? Plug in x plus h. So what do you write? F of x plus h over? Are you with me? Over g of x plus h. Okay, what goes next? Minus f of x over g of x all over h. Wow, that really does not look like what I wanted. Well, so we're screwed. Give it up. Let's give up. Go home. That's it. Done. Just come back May 5th for the AP. See ya. No? Is it May 5th? I don't know. I made that up. All right. Well, actually, it's not that bad because how do you subtract fractions? Be a common denominator. What would it be? What's missing here? Multiply top and bottom by? G of x. Multiply top and bottom by? G of x plus h. So on the bottom we end up with g of x times g of x plus h. That's sort of a g squared thing, isn't it? Sort of? Really? Not? No? Yeah, well, How about we do that? Let's actually get the common denominator. See if that helps. Okay, so all of that mess equals the limit as h approaches 0. All right, and so multiply top and bottom by g of x here, right? So I'm going to get, let's see, g of x times f of x plus h in the numerator over the common denominator, g of x times g of x plus h. I'm not subtracting yet, I'm just getting common denominators. Minus, multiply top and bottom by what? All right, so I get f of x times g of x plus h over g of x times g of x plus h. Now, let me cut to the chase. How do you divide by h? This is one big fat fraction once you subtract, right? How do you divide a fraction by a fraction? That's h over 1, isn't it? Multiply by the reciprocal, 1 over h. Okay, that's going to come in handy. All right, well, can you subtract now that you have common denominators? All you do is what? Subtract the numerators and leave the denominator the way it is, right? Okay, so let's write that out. People forget that, I don't want to assume nothing. So this equals the limit as h approaches 0 of, let's see, g of x plus h times f of x plus h. I'm going to write it like this. Minus f of x times g of x plus h over a common denominator, h times g of x times g of x plus h. All right, now, what did I want? Low, D high. Okay. There's low. Where's D high? I don't have enough. I'm going to hint. I'm going to add 0 again. Remember, I wanted low, D high. Well, what's missing for F prime? What if I wanted this to be F prime? What's missing? Minus F of X, right? But I'm multiplying this by G. How about if I do minus G times F? Do you see what I did? Because then you can factor out the G, and then you're going to left with F prime. But if I subtract that, remember, you know how to add 0, right? If I subtract that, I better add it or change the whole problem. I'm not solving the same problem. Well, that's nice. If I factor out the G, I have F of X plus H minus F of X over H. That's an F prime. But wait, what do you factor out over here? F of X. Well, I wanted that. But then I want G prime. That's not G prime. I get G of X minus G of X plus H over H. That's not G prime. What's G prime? The limit as H goes to 0 of G of X plus H minus G of X is backwards, right? Over H? Well, what if I make it backwards? What happens if I change the order of a subtraction? It changes the what? The sign. Okay, that's good. Let's do that. Let's see. Wow, we're about out of time. All right, you know what? We'll leave it at that point, and we'll finish this tomorrow. But we're almost there. Huh? Well, you have the homework sheet. I just gave it to you. Okay, so all right, let's save it here.